Excellent. So this was a really, really interesting session with all different backgrounds and different perspectives about embodiment. And I have actually many questions I want to discuss with all of you. I don't know whether is Ryota still around. If you can turn on camera, maybe joining us for the discussion here. Excellent, great. So I think the most important discussion probably we should have here is something to do with consciousness and contingency and all the important keyword, hard embodiment, soft embodiment, and so on and so forth. And I just want to come back to this question that Ryota asked at the beginning of his lecture about whether subjective experience or consciousness, in other words, is important for intelligence, or consciousness and artificial intelligence have the common root. Is this anything useful, anything beneficial for machines or or humans to be intelligent? I know this is a hard question to begin with. I don't know if anyone want to talk about the importance, benefit of consciousness. Let's see who can start. Antonio, maybe you can kick off the discussion in terms of consciousness from your point of view.
It's not. Thank you for me for. So I think this is well. Let's see. During Professor Kanai's talk, he had this notion of consciousness as the possibility of having, how can I say, rehearsing reality without the need to be there. And I think that definition is one of the nicest I've heard, because it really it's a simple way of putting things that opens to to some thinking. I also noticed what he said about not needing a body, not needing a physical embodiment, but the key being the action reaction that you get from the environment. Of course, in principle, you can think of this without an embodiment, but in reality, you cannot. So whatever you do, even virtual reality, you have a physical interaction, which is through your eyes and through light. So I don't really think there is even the theoretical possibility of having consciousness without physical interaction with the environment. If I'm to be a little bit, integralistic in my views. So I really think that the physical interaction is part of, integral part of consciousness.
That's a really, really good starting point. And I've never thought of this, simulated embodiment is going to be the real embodied experience, subjective experience or not. I think that's a really interesting point from Maki's point of view, I think. But the real timeness, right? How we do the real time intelligence. Yesterday, we had also a discussion about daily physics, right? How to deal with daily physics. If you grasp, some object that you don't know, you cannot make a models in your brain. You cannot react in real time. You just have to deal with this daily physics. Is a kind of interesting discussion also in the context of real time reaction, real time interaction. Anyone else want to give opinions, suggestions? Kind of people thinking about what to say. It's a very heavy
consciousness.
Topic.
Consciousness, right?
Yes, Kenjiro, do you have any? Your robot has completely no brain, no computer, no brain, mind. No computer.
Yeah.
What do you think the benefit of consciousness for your review?
Okay. So I think the conscious. We would like to set the robotic mechanism without any, how can I say, not too much intelligence, but like we would like to embedded intelligence we would like to realize. So the one of our consideration is we set the really effective passive mechanism which can memorize the shape of the grasped object. So the one of the, how can I say, can I just quickly share the screen? Okay, as you can see here. So this is the grippers we developed, but we can think this is one of the shape gauge, as you can see here. So there is no conscious, but the embedded conscious. It means it can keep the shape without any sensors, but the mechanism itself has that function. And also let's think about the mechanism, which includes the information as a inside of the body is one of the things is key or organ, mechanical organ, and so on. So my opinion is we can think the mechanism as memorable. How can I say the memory function included the body, and also at the beyond of the memory, there is a consciousness can be achieved. That's my opinion.
Okay, thank you. I think that's an excellent illustration of how physical system can have a memory without having brain. But having said that, I think this memory or processing can not go too much beyond where rather low-level primitive memory. And one of the discussion we had with John and Bryson yesterday is, the consciousness is no big deal, but more difficult thing is how we can make our artificial system more moral, ethical, and more legal and stuff like that. And that level of responsibility in our information processing is probably another completely different level of discussion. I don't know, Ryota, do you have anything you want to shoot us back after listening to all the discussion presentations so far?
Antonio's comment made me think about the kind of distinction between a virtual simulation versus physical, like real interaction. And so this is a little bit tangential to his comment, but in consciousness research, there has been a debate about whether simulation of the brain is conscious. So let's say we have perfect simulation of the whole brain, well, let's say at the molecular level. And is it conscious? And we don't have a clear answer to this, but what's interesting about integrated information theory is that according to that theory, simulation of consciousness or the brain does not generate consciousness. There's some sort of philosophical theoretical reason for this, but I think it's an interesting question. We don't know whether we can test it empirically, but we know that the simulation of water is not water, right? So according to some theories, consciousness corresponds to the physical interactions happening in the real world. So from that perspective, we actually have to have something physical, and I don't have an answer to this, but I think that's a potentially interesting thing to think about. And also from my viewpoint, sometimes engineers have very naive view about consciousness, but on the other hand, consciousness researchers also have naive views. And my feeling is I got interested in AI research and maybe to some extent robotics, because even if engineers don't think about philosophical aspects of consciousness, I think there's a chance that they just come up with some architecture that generates consciousness just by pursuing functions. So yeah, that's so I often feel like there has been like this a big trend of deep learning, and people came up with all kind of interesting architectures and concepts. And yeah, then I felt like there are a lot of new ideas that I didn't see in neuroscience. So from there, their intention is not necessarily about solving consciousness, but a lot of by pursuing something different, but they may come up with artificial consciousness without knowing it. So that's kind of scary for anyone interested in consciousness and try to research on it. But I think for that reason, it's very important to be open to interdisciplinary approaches. Yeah, that's my kind of general impression.
Thank you very much, Yota. Anyone else?
I jump in then. I felt that I was invited from my Kanai sensei. Thank you very much. In the philosophical sphere, the philosophers are talking about the deep, hard problem of consciousness. In the term of hard problem of consciousness, it means that if we're going to study neurons, or if we're going to copy the neuron activity into the real computer world or whatever, or create our artificial neurons and create new brain, artificial brain, then they think that the brain will be there, and then there will be a consciousness like a click. But there's other philosopher clans that is talking about the soft problem of consciousness, which is more talking about the importance of the bodily movement and how the interactions between peoples. So they are the clans that is talking about the in-betweenness of what is happening between the environment, human and environment, human and substances, and human and humans. So I am on that kind of side. That is the reason why I have been said in my presentation that we have to divide that kind of substantial problem and what is actually happening, which in Minakata Kumagusa's words, he's saying that it is events that is happening there. So I'm wondering how you guys are, as an engineers, going to connect all these problems. And for what Tadakuma sensei has been saying, I'm quite sure that if we look at the material, substantial materials, it seemingly has its own memories, right? But then it doesn't. Even if it has its memories, it doesn't really mean that it has a consciousness. Because it is just reacting to the world. So from my philosopher's point of view, I would like to ask, what is this, and of course, most of the other scholars are talking about the soft side or the haptics or the importance of the softness of the robotics right now in this session. So I was wondering, what is the goal that you are setting in terms of setting this, the soft robotics?
Yeah, I think that's a really, really good point. I think I need to go down to Tamar about your definition of hard embodiment. I think this touches upon really nicely about what's embodiment, what's not embodiment, how we can go beyond mimicking biological organs, but we need to have a biological counterpart or replica of consciousness, and dividing into, what did you say, experiential, behavioral, and neural connections. I think this was a really, really interesting way looking at how we can go beyond what robots, the kind of robots we had before. I don't know, what's your view how we can make a step closer to what we make conscious machines?
So obviously my interest, for my purposes, if the technology we're interested in becomes conscious, it would be a disaster, because the last thing we want is, an arm that is attached to me just doing its own thing and maybe, you know, doing the wrong thing and maybe something I don't want to take responsibility over. So at my end of the spectrum, we're very happy with no consciousness and minimal intelligence. But having said that, I think, you know, body templates and biological templates are wonderful for inspiration, but, you know, kind of the idea of soft embodiment was really kind of stemming from the frustration of like the mismatch between how, you know, how ineffective current technology is to mimic the function of the hand, and the frustration of the kind of the hacking solutions that engineers were coming up with in order to kind of insistingly try to make a prosthetic behave like a hand, and at the same time opening up to augmentation technology where embodiment, you know, is a problem. We don't want to use embodiment as a template for augmentation because we don't have the neural infrastructure for an extra finger or for a tail or for a tentacle. So we want to see how we can recycle the resources, the neural resources that are there, sensory motor loops that are already functioning, in order to accommodate these extra technologies that, you know, can really enhance our daily life, both in terms of productivity, but also in terms of healthcare solutions.
Excellent. Yeah, thank you, Tamar. Perla, I think you were talking about the perception, haptic perception, and perception is something more than sensing, I suppose. What's your views step towards perception and possibly more deeper understanding of the world? What's your approach?
Yeah, I mean, like I think in general, like my experience at the beginning with rigid robot was that you have a sensor and you have to actually deal with its own limitation, and also the body is very limited in like its interaction ability, and so this means that you are limited in understanding the world from that. So I'm trying to use the idea that we can design a sensor and the softness of the body to be able to actually augment, in a sense, the interaction possibility with the world, and so in a certain way also understand better from the sensor what is around, and so simplify in a way the perception problem, because you can increase like your taxonomy exploration action, and also you can maybe tune and change the morphology of the sensor online, and be able to, in a certain way, separate like clearly data that are coming from the sensor and be able to distinguish different kind of object or tactile features. So that is the idea of trying to use the embodiment to simplify the perception problem, and looking at designing sensor that allow to exploit compliance in this respect.
And action part is another interesting point, right? This perception should be guided by action. That was one, or should be or should not be. I don't know. There's another discussion yesterday.
I think that there are both. So there are definitely parts that are active, but you can exploit the compliance, the passive part, by designing the sensor with like a particular morphology like that have some passivity, but that of course increase, like change the way in which the let's say a contact event and tactile event are filtered by this passivity and arrive to actually the actual sensor. So there are, in my opinion, both aspects, of course. Right.
So the issue of action, implementing actions in our perception, or consciousness, or if you like, what's the panelist's view about how we should think about action? Is action essential or action not necessary? Or what do we mean by actions? That's another question we had in the first day, whether plants have a consciousness or not, right? So I think it is another interesting idea. If consciousness need a brain, or do we need a brain to make actions or conscious? What are all the sphere of discussions, topics, how we should think about action? Because if we build robots, we implicitly are forced to think about what motions to make, and the motion is one of the important things that we look at. Anyone have any suggestions how we should think of?
I had some thought on this. Yeah, I think action is really essential for generating a sense of self. So sometimes, like, we do experiments on simple AI systems, and initially, before the agent learns things, it confuses which part of the environment belongs to them. So yeah, but it seems like really important for AI to distinguish which part of the environment is controllable and which part is has more uncertainty. So, but by performing action, they learn which parts they can control, and I think that's the most primitive form of sense of self. And so without action, probably there's not much distinction between your own body or own your part against the the rest of the world. So in that sense, when I talk about consciousness in the context of robotics, maybe this kind of like sense of self or sense of agency, or just having a model of that self is like really maybe most relevant aspect of consciousness for robotics engineers.
Yeah, I'm pretty sure Antonio has a lot to say about this, because you're building basically the physical avatar, making actions in the real world in remote location. What's your view? What do you think about it?
No, I definitely think that action is just part of the game. I think we have said that already, and the possibility of thinking of an action and the reaction that you will get is part of the expectations that you have that will match or will not match, defining in some sense who you are, and the fact that there is a you that is simulating something and then we'll check. I think this is crucial, and that was one of the points. Why are we making prostheses or avatars, which are glorified prostheses in my view, or total prostheses that have compliance and variable stiffness and softness, and our hands are soft, because we want to have the effect of interaction that is as close as possible to what you would have through your body, and your body is soft. And I would add one element to this, that is not just interaction with the environment, is interaction with your own body. So in prosthesis, for instance, we found that a huge difference between what we have been doing with our soft hand prosthesis and previous experiences, that people can touch their own body. So there is something that I think is related to Tamar Makin talk. I would say that it's not surprising at all that people, in some cases, prefer a tool to a hand. I mean, I've been working with tens and tens of people with amputations, and I know often I met people who have two hands and people who have a hook, a very rough, simple steel hook, and a anthropomorphic hand. And sometimes they when you ask when and which one do you prefer, often they say, well, when I am at home or when I'm at work, I always use the hook. And I use the other hand when I'm out, just for the social part of it. So it's normal that we use tools. And we ourselves use tools to do things rather than the fingertips of our hands. So that's for me, a normal thing. But if you go about touching yourself, something that you do every day, touch your body or touch somebody else's body, then you don't really want to have a hook. that doesn't work, or something, strange. So it's this loop that you have with your own body or with your own image of your personal self that, to me, motivates the need for a natural motion and natural interaction.
Hey, Tamar, do you have anything to add?
I mean, obviously, we're creating these devices for a purpose, and I would cynically argue that self-touch is low, very low in the priorities at the moment, where the people are actually being disabled. But I do think it's a really, really important point when we're thinking about augmentation. So if you take someone that is already able-bodied and you want to extend their motor capabilities, then then these kind of simple consideration might actually weigh quite a bit. If it looks weird, I don't know if people would be comfortable walking around with it, and then they might not be using it. So I would say it's a really important consideration for augmentation, but maybe people that are disabled, maybe not so much.
Well, another interesting discussion is whether the difference between tools and not tools, your own body. Like we use a lot of different kind of tools, obviously, but we, on the other hand, we have a very general purpose body. Is there, maybe this is a question to Tamar and also maybe Antonio, that we have prosthetic hand, whether this prosthetic hand is still a tool for the user, or it becomes, if there's any moment in time where using it becomes a part of your body. Is there some important, interesting discussions, or is it?
Yeah, so I mean, prosthetics are definitely overlapping with tools and with body parts. So they're not, I mean, they are part body, part tool. And, some manufacturers of prostheses are, unabashedly creating, for example, the gripper by Ottobock, which is, very well liked by many amputees, because it allows them, again, to do maybe more than what they could have done just with, with a partial handle. You have to remember that most of the cosmetic hands at the market are actually not operable, so they're completely static. So I'm not saying they're not useful, I'm saying they are as useful as a stick, right? But again, going to augmentation, which is, this new emerging field that is coming out of from prosthetics, augmentation is by definition not a tool, because instead of replacing your hand function with another function, even a better function, you're extending your available function in order to accommodate and do more. And proper kind of true augmentation is really designed to free up your hands to do something with your hands in addition to the augmentation devices. So this really opens up, both on a cognitive level and a motor control level, a completely new territory that humanity hasn't really covered before.
Right, yeah, excellent. Antonio, anything to add?
No, I agree in part with this perspective of augmentation that is different. I like these augmentation things, so we are trying to do something. I'm not completely sure that I wouldn't adapt my mind of, thinking of my third hand as something useful that I can use, which to me is a tool. I don't know. I mean, probably Tamar has more experience than I do, and the brain images are different, or the projections are more close, or are far from those of tools. But I'm not sure how. I mean, why do you say that it's completely different, Tamar? Why? What is the
because
argument?
In traditional tools, you use your hand in order to directly manipulate an object, which is the tool, to do something else. So it's similar to your avatars in a way. Whereas, because your hand is engaged in order to accomplish this task. But with pure augmentation, we want your hands to do what hands are doing, and that your extra arm would do another thing that the hand is doing without impairing your hand. So the whole point of augmentation is that your hands are free to do what they want to do. And in addition, you have an extra arm and hand that you can control in a different way, independently of your hands. And that's quite novel.
Yeah, I agree. Although, if you think of a surgeon that is doing some laparoscopic operation with two hands and has an assistant who directs the camera. So what the surgeon does is ask, look at this, look at that, or move right or left. So it's really that the third person is doing, an augmentation. And this is how really they feel. And so that there, I mean, in some cases, it's like having, a third hand for moving things.
That's a really, really fascinating idea of the sense of agency and sense of ownership, and if two persons can work together or not, and or even more people can work together. I think that's a real challenge for the embodied intelligence, I think. So I think in this context, I want to come back to Maki's idea of a contingency, because I think that's what we probably need to understand better about how embodiment and contingency come together. And my question to you is, I asked you earlier, but what if we have a static body, or if we have a dynamic body, growing body, or if we have 2 people, 3 people working together on the same task, same problem? How can we understand the contingency from your point of view? Like, do we need, or in the first place, do we understand contingency as something unexpected or unstructured? Can you tell us about your definition, characterization of a contingency?
Thank you very much. Contingency is more about unpredictability or uncertainty, I should say, using Antonio's word. It is not static at all. It is more stated in a dynamism. So it's not only about the subjectivity itself, but it also has involvement with others and environment. And so that's how, and that's where the contingency happens, I guess. Can I just quickly go back to what Antonio and Tamar was discussing on perspective 2. Based on Heidegger. Sorry, I'm a philosopher, so I just go back to Heidegger anyway when you talk about 2. But the dangerous part of 2 is if you're going to think your hand as a tool, or it means that you want to do everything with your hand. If you feel that it's not a tool, then if you feel that artificial hand as not as your tool, it means that, as discussed, there's a sense of ownership which doesn't go beyond most of the needs that is unpredictable. Am I making sense to you? So if you're thinking the artificial hand as a tool, then you will start inventing a lot of other things that you can do with this third finger, or third hand, or 6th finger or tail or whatever. It's because that you're going to interact with the environment with other perspective. But if you have the sense of ownership, if you think that the artificial hand is your own hand, then there is a kind of limitation that is tapped there that would limit you from going beyond the ethical or morality of what the body can do biophysically, should I say? Yes.
It's very interesting. So we should own it, right? And otherwise we just treat it as a tools, and that's not going to be. What's the problem of not having ownership?
It's the maximization of your need or your wishes, should I say. the problem that is embedded in science and especially technology is it has two sides of the same coin, should I say. It has a very good positive impact to society, but at the same time, it can bring something very disastrous, as Tamara said when we were talking about consciousness, that consciousness might lead to disaster, Tamara said. So I think it is a kind of, we're talking about both sides of one coin, equiprimordial, we say in Heidegger's terms. But we have to be very careful when we are developing new tools, because we might maximize our wishes so that we can start, inventing a lot of things that goes beyond the morality of what we are living as human beings. That might also lead to contingency as well.
I just want to add an analogy from cochlear implants where it was hearing aids, where at some point they updated the hearing aids to have kind of automatic filters in order to filter noise based on the environment. And users did not like that. They want to decide what is being filtered and what they can listen to. And I think that's a really good example of why we should provide users with the agency to decide if they want to limit their own agency.
Okay, and so the final point more to engineers. So there's a question in the chat. Having learned a lot about the notion of consciousness and the contingencies and all that ideas from philosophy, is this going to change our way of building our robots or technologies, or what are the aspects we are doing things wrong, or whether we know whether we should do it in a better way because of these ideas of consciousness and in contingency. I don't know if any engineers, Paula, Kenjiro, Antonio, anything we should build things differently? Well, one of the things we definitely need to do is a sensor, more sensors to be integrated, right? If we don't have a sensor, if you don't have a way to sense the world, I think that's it's kind of dead end. Or am I wrong?
That's very, very difficult, question and the issue. Like the robot doesn't have any such a sensor or sensing function which can recognize the environment of the robot, right? That's a quite difficult still.
Well, this is a really interesting question to Kenjiro, because your robots never have sensors.
Embedded sensor.
And you can do a lot of things without sensors, and that's a really interesting view, right? You have a mechanical intelligence that solves all the problem without sensors, but somehow biological agents, biological systems are very different. We always have a lot of sensors, and I don't think any animals are without sensors, right? In nature. So what's your reaction to it? You still don't need sensors.
So my answer is that I'm really interested in the configuration of the jellyfish. The jellyfish has the touch sensor, which but without any brain they have, right? They don't have any brain. So, but they can react to the environment. By using the mechanical switch sensor, like it's the no brain, but the reflex motion they can do. So one of my way is to use the reflexive motion. So that's the one of the way to realize the without any sensor, but the sensing function can be realized by just only the mechanical configuration. But still, how to react, how to cope with the contingency is really still the big issue. So I really would like to consider much more about this. But one of the things is the reflexive motion is reduce the degrees of freedom. It's really good for the simple configuration. We realize the as a soft robots and so on. Just we can think the, how can I say, the bulb, not the actuator, but the switching configuration for the soft robots to realize the quasi redundancy. Very easy to use, or quasi-redundant sensing we can realize by using that sort of the reflexive motion inspired from the nature. That's my opinion.
I think that definitely sensors are something that help to develop ownership of the body, understanding of the body and consequences of the action. So they definitely are needed if we want to go towards like developing consciousness. I mean, simple organisms can maybe not use brain or have limited sensing because they are in their niche and everything has been, let's say, evolved to stay in that niche and like to solve the problem in that like specific environment. If you want system that can be more adaptable, can be deployed in different kind of environment and that can adapt their behavior and survive in different kind of environment. I think they need to learn which is the consequence of their action and interaction with the environment. So they need sensor to actually develop these capabilities. So
yeah, excellent. Yeah, I think sensors. The reason why Kenjiro is not using sensors, and I myself is not using a lot of sensors in our robots, because sensors are a really difficult problem, and we don't really have a really reliable, cheap, and unbreakable sensors, reliable sensors like biological systems, and that's why we always come up with solutions. Or try to come up with a solution without sensor, without relying on sensors, right? We have the coffee machines in our office, and the coffee machine is wonderful coffee machine. It does a lot of different kind of things, but it just broke down because one sensor is broken, and all other functions are just blocked because of this one stupid sensor. And the sensor technology is really a challenge still in robotics, and that's what we're blocking us to make our machines more closer to conscious machines and stuff like that. Excellent.
For me, just one comment on this. In our arm at this level, if you count the nerve fibers that go down to the hand, there are some 350,000 fibers, and less than 5 to 7% are efferent. The rest is afferent. So there is a huge preponderance of sensors with respect to actuation. So my colleague, Professor Assman, who did the count as a surgeon, says that motor control is basically a sensory phenomenon.
Interesting. Yes, yes. We have a lot of sensory information coming into our body, and that's actually also the trend in machine learning, AI technology, like how we can process a lot of data, lots of sensor data over time, and that's probably one of the big challenge we need to work on right now. Okay, any other final remarks from the panelists? Is anyone any comments that what we learned from this discussion, what we should be doing in the coming year, coming days?
I just want to say, because this is the closing session, thank you so much, Rumia, to you and your fantastic group for putting this all together. Such a wealth of, information and perspectives, and so beautifully integrated. It was such a pleasure to take part. So maybe we can do a round of applause for Rumia and his team.
Thank you. Thank you very much. Yes, wonderful. Any other comments from panelists? Anything else? All right. Well, then thank